Good afternoon to one and all. In the previous class, we discussed about different types of soils where we have to construct a huge amount of projects. So that first of all, we need to know the properties of the soil. After that, we have to do a small type of investigations regarding to our project. After that, we have to do our construction work. Why? Because without knowing different properties of the structures, still we have to constructing means after the construction process we have to face a huge amount of problems. After that, we have to lose our total money which was invested on the project. So that basically we need to know the properties which are having on the site level. That means normally in few of the conditions we are having properties, so that we need to take another properties from the site level also, so that in the different layers we are having different conditions of the soils. So that due to this uh, transportations and erosions conditions, we have to face huge amount of problems with the soils. First of all, we need to know the whatever the soil on the top level, whatever the soil on the middle level and bottom level, all those things we need to know after the testing of these properties. So that basically we are having four types of soils. Regarding to these ground improvement techniques, we need to know all of those properties. In the previous class we discussed about these sandy soils and their particle size. Normally these particle size lies between 1 to 2 millimeters, but there is no bonding between the particles. Why? Because all those are related to huge amount of particles. That means the particles is greater than 1 to 2 millimeters. So that there will be no bonding between those because of their size and shape and another chemical properties. All those are reflected because of this bonding nature. Another one, we are having these silty soils. And in the silty soils, we are having a particle size ranges from 0.002 to 0.05 millimeters. Previously, we are having 1 millimeters to 2 millimeters diameter of the each particle, and the shape will be varies according to their transportation and other site levels. In the silty soils, we are having 0.002 to 0.05 millimeters, and we are having some amount of bonding. That means when we mix a particular 2 to 3 drops of water in a pinch of material, definitely there will be a bond formation. But this bond formation will not be for huge amount of time. When we apply a small amount of force onto the ball, there will be a breakage will be applied after drying also in wet condition also. Both conditions, the breaking of force on the ball will be showed due to this application of small amount of forces on silty soils. Because there is a chemical properties and binding properties is very low in sandy soils and silty soils. Another one we are having is the clay soil. In these clay soils, majorly we are having particle size is very less compared to front two materials. That means silty soils and sandy soils. But in case of clay soils, the particle size is very less compared to those two. That means the particle size is as minimum as 0.002 millimeters in size. That means very tiny particles or small particle size. Normally, this kind of particles are having huge amount of binding properties. They will stick one to each other because of this fineness is very more. Uh, while we have to observe when we are cooking some amount of rice, there will be no bonding between the rice particles while they are in dry condition. After cooking, there is some amount of bond between those rice particles. Why? Because we are treating with water and stream, so that there will be a binding will be occurred onto the particles and others. When we have some amount of flour, simply we are having a minimum of 1 glass of water to 1 2 glasses of this floor. That means there will be definitely bond formation between these floor particles. Why? Because these floor particles having very small particle size compared to these rice particles. So that there will be definitely a particle and binding properties, because we have daily we are observing those two particles, rice particles and these floor particles. Likely in this clay salts and sandy salts and other different soils also we are having different particle binding properties because of these particle sizes and their chemical properties. That means chemical properties are measured what amount of different types of chemicals present in the particular soils, so that there will be a definitely change of different types of chemicals. So normally in the silty soils we are having more amount of silica, but in case of clay soils we are having more amount of this ferrite and other montmorillite light chemicals, so that there will be a huge amount of binding properties in the clay soils. All these are explained in the previous class. Today we have to discuss about loam soil. What is the loam soil? What are the different chemicals present in these loam soils? And what are the properties exhibited by these loam soils? And particle sizes varies. Okay, these things we need to know about these loam soils. First of all, loam is not its own particle type, but it is designed for the soil's conditions certain combination of other particles. That means it is not naturally occurring soil. It is the combination of two or more different materials from the collection of different fields. That means few amount of soil can be collected from the one area, and another few amount of material can be collected from the another area. Those two things will be mixed to form a particular quantity of material having different chemical properties and binding properties for those particular soil. Why? Because in a few of the sands we are having so much of these sandy particles and others, so that we are having less bearing capacity. We all learned about this bearing capacity of the soil in RCC. That means well, we have to have to go for a design of particular amount of footing. That means this soil bearing capacity will be useful. Okay, so total load by soil bearing capacity will have to design the area of the footing, so that this soil bearing capacity having huge amount of response for those different soils. Okay, next second point we are having is the way of other particles combined in the soil makes them loam. That means the way of other particles combined in the soil. That means the different ways to combine. That means the quantity will be varying. In some cases we are using 60-40 ratio, in some cases we are using 70-30 ratio, some cases we are having 50-50 ratio. Like that the soil quantity will be varies from whatever we are taking and how much quantity we are having. That means that simply depends upon the strength we require for the particular soil. For the attaining those kind of strength, how much amount of percentage required we have to check in the site itself. That means we have to do some soil investigations, so that how much amount of sand, how much amount of materials required to attain those particular soil bearing strength, so that we have to take which kind of material. Those kind of material is available in the nearer site or far up to the field, so that what is the total amount of cost we have to take. Is there any supplement materials for those kind of actions, so that all those are involved in this preparation of these loam soils. Next, third point we are having is, for instance, a soil that is 30% clay, 50% sand, and 20% of silt. These things are previously we discussed that we need to have two or more different materials for the formation of the soil. Likely they are here representing 30% clay. That means totally soil we are having 100%. In those 100%, they are mixing 30% of clay and 50% of sand, another 20% of silt. That means those three materials, like in our concrete we are having sand, aggregates and cement, so that in those sand, aggregates and cement we are having huge amount of aggregates, small amount of sand, and after that we are having macro nature of cement, because cement is a binding material. Likely in the mix we are having clay is the binding material and silt is the, okay, likely we have to assume depending upon their particle sizes and quantities we are using in the particular mixture of these loam soils. All those depends upon the particular soil bearing capacity whatever we required in those particular soils for constructing the projects and attaining a huge amount of lifespan throughout his life. The next fourth point we are having is the labels clay loam, soft loam, and sand loam are used in the referred soil so that compared composed predominantly in those ingredients. That means whatever the materials they are used in those particular combination of the materials for those constructions, they are simply using as a label for particular type of construction. We are using this kind of material so that the total structure is retained for this particular year, so that all those studies they can do in the particular laboratories, so that they are having a clear cut idea and properties changes whatever they exhibited, how much amount of load they will attaining, is there any shear strength developed in those particular soils, what is the liquid limit, up to which liquid limit the soil bear, what is the plasticity index. Okay, all those things we have done in our geotechnical engineering lab itself, so that all those properties we need to check for particular kind of soil while we designing. That means the normal soils we are having different properties, so that all those are in our codes, but we are artificially developing, so that we need to know what is the soil properties for particular mixture. All this we have to note, and those things will be useful for the designing of the structures, because we need to design a particular amount of structure, so that the total structure is dependent upon its foundation level, so that the foundation we need to design for these soil bearing capacities. So those are directly proportional to the soil bearing capacities foundations. If the foundation is weak, automatically the total structure will be collapses. That collapse means a normal cracks will be absorbed on the structure within 5 to 10 years of the after the construction. That means in the beam column joints and in the column itself, in the slabs itself, they are having a micro and macro cracks will be observed after the construction of the prop, because of this stress distribution will be varies from footing to footing because of this soil variation. All those are comes under these properties of the soils. Next one we have to discuss about different laboratory tests for problematic soils. That means problematic, in this heading we are using problematic soils. That means some soils are creating disturbance to the structure, so that we need to locate what are the problems we are facing from those particular soils. For those problems, what is the solution? Is there any artificial methods or any man-made methods or any chemical accelerators we have to use or any physical actions we have to do? All those can be we need to know because of these problematic soils. So we need to do some kind of investigations, so that these have to mitigate the problems arriving from these problematic soils. This is the main theme of this heading. Next thing we have is ESG, that means environmental, social and governance. All those are comes under these in situ laboratory testings. While we go for a particular sand or any particular soil type, we need to know the parameters. Why? Because some of the soils having huge amount of water bearing capacity, some of the soil will not bear huge amount of loads, so that we need to know the particular property. Why? Because whenever we are constructing a particular structure, what is the main purpose of the structure? It is a load bearing structure or normal structure. Why? Because many of the countries they are simply constructing without knowing these geotechnical parameters about particular soil, so that after the construction they will simply falling and there may be huge amount of accidents due to this less take caring of soil properties, so that we are losing a huge amount of manpower, and in terms of their accidents and others, like in industrial areas also we are having explosions due to these land settlements and others, so that these properties we have to know as much as possible. Why? Because to arrest those accidents and human loss in the structural losings. First of all, we are having environmental. That means whenever there is a accident, means automatically there will be a disturbance to the environment. That means whatever the vegetation here they we are having, and what is the manpower they are having, and is there any wild animals, all those can be affected due to this environment structural failures and environmental problems, so that we need to mitigate. Next one, we are having social. That means social and a word manaki related to our man, that means humans, so that there may be a human loss due to these structural failures. Next one is the governance. Whenever there is a huge amount of failure of these structures, there may automatically the governance will be striking due to these actions taken to the mitigation measures and others. So likely in many of the states we are facing a huge amount of floods and other things, so that there may be striking of the governance to the states, so that they have to take a huge amount of mitigation measures. They have to daily supply this food and water. They have to create artificial homes to the people who they are suffering, so that we need to construct a big amount of projects by knowing their properties. Why we are discussing all those things means, whenever we are constructing a particular dam, if the dam capacity is designed for 200 tmcs and others, the in some of the year we are having huge amount of rainfall, so that there may be a rain having huge amount of density, rainfall density, so that the water in the dam will be flowing overly, so that the villages which are nearer to the dam, all those are affected due to this huge amount of rainfall, so that we have to face a huge amount of problems by, because we are designed the project for particular capacity, we are having exceed amount of water, so that all the water we have to use in a particular proper manner, otherwise these things will happen. So that in some cases we are having some amount of failures due to this excessive amount of loads, and some amount of మనకి పల్లెటూరులో వాటిలో ఎక్కువగా యొక్క కాలువలు మొత్తం కూడా కొట్టుకుపోతూ ఉంటాయి కొన్ని ఏరియాస్లో. వై బికాస్ ఆఫ్ దీస్ ఫాల్టీ డిజైన్స్ అండ్ అదర్ కన్స్ట్రక్షనల్ ఫాల్టీ కన్స్ట్రక్షన్ ప్రాక్టీసెస్ బై పూర్ వర్క్మెన్షిప్. ఆల్ దోస్ ఆర్ కమ్స్ అండర్ దిస్ environmental, social and governance. In recent years, the importance of soil in and rock stiffness parameters in geotechnical engineering has designed increasingly recognized by driven part by the requirements of EC7 and calculating severability limits of state conditions. That means, as things we are previously discussed, all those are here. That means whatever the actions we need to take, what are the properties we have to know while constructing a particular project, all those are kept in here. Next we are having is specialist in situ testing. That means in situ testing means whatever the plan we are having, so that we need to go for that plan, and we need to check the soil parameters up to some depth. That means whatever the foundation we are having, we need to go for that foundation level, and we have to take some rapid level soil samples. That means rapidly we need to take in a particular manner. That means by taking a particular manner, we have to get some kind of wrong value, such that we have to take a rapid level these soil samples, and we need to check those, and we have to attain certain properties. It provides a number of specialist in situ tests for the measurement of soil stiffness, either as a standalone service or part of a wider site investigations backed up by the proven technical and analysis of experience. That means they have to take a standard service. That means we need to use some specified geotechnical engineers and other lab technicians for the conducting these site testings as a part of wider site investigations. That means wider means so large site. That means huge amount of area we need to investigate, so that we have to require huge amount of manpower for conducting these geological investigations for attaining properties of such projects, and backed up by the proven technical and analytical expertise. That means all those values we have to use in a particular sheets. Those sheets will be analyzed by some technical experts. That means those who are having some kind of experience in those particular levels. That means geotechnical engineers, that means who are the doctorates and other things having this expertise or knowledge in this particular geotechnical field. In our civil engineering itself, we are having different fields. That means mainly we are seeing these structural engineers. Those are useful for designing of huge amount of structures and their designs. After that, we are having this geotechnical engineering. Those are completely responsible for the calculation of these site parameters. That means soil properties and their parameters, and their role is to increase the soil properties by using different additives and admixtures. And next one, we are having these transportation engineers. That means the transportation engineering, we are having mainly they have to develop different kinds of road pavements and road thicknesses to decrease the accidents and other traffic problems. Next one, we are having is environmental engineering. In environmental engineering, mainly we are focusing on these water problems and drainage conditions and others. We are having mainly water as a major source for the any civilization, such that we need to have some amount of water for drinking, some amount for industrial purpose, and some amount of for farming. Agriculture is the main base of for our country. So likely we are having different properties with this water, so that we have to purify those in a different manner, so that we have to create some artificial materials for proper stirring and other conditions. Next one, we are having different water tightening structures. All those are coming to this WRA, water resource engineering. Also, we are having some kind of specialization, likely construction materials and maintenance, remote sensing and GIS. All those are having different specializations useful for our civil engineering. That means civil engineering problems we need to face by using all those technologies. Next point we are having is, first one, we need to use some experts to know the properties of the particular soil. Those things have to note in a particular sheets, so that they have to analyze in a particular group of members who are having some sort of knowledge on these geotechnical parameters. And the second point mainly we are having is the borehole and surface seismic methods, such as downhole, crosshole, surface reaction, refraction, and multi-channel analysis in the surface waves. This borehole term mainly used for, normally we are seeing whenever there is a need of water in agricultural fields. Normally we are using these boreholes for driving water from the ground surface to the below the ground level to the above the ground level. We have to redraw the water, so that these boreholes are used. Normally, in case of our geotechnical engineering and ground improvement techniques, these borehole data, that means we have to collect the properties of the soil from the ground level to the top level, so that we need to use these borehole parameters and other surface seismic methods. That means surface seismic method. In these seismic methods, we are using normally wave technology, S waves, P waves. Normally, we are having while we are studying about these earthquake engineering, or primary waves and secondary waves we are having. Whenever there is a settlement in the ground layers, automatically these waves will be coming from the particular seismic point, so that there will be a huge amount of collapsible in the soil. So that what are the different densification methods we need to have while going for the seismic methods? First of all, we have to have this seismic equipment. After that, we need to choose some sort of points. From those points, we need to have some kind of vibrations we are artificially pumping into the earth level, so that due to those vibrations flowing, that means some kind of soils having huge amount of density. If density is more, automatically these waves will go in very slow manner, such that there will be take huge amount of time for going. If the density is very less, such that the waves will flow easily, and they will reach at a point certain in a less span of time, such that these seismic methods are used for the calculation of particular density parameters of the soils. Next one, we are having downhole methods and crosshole methods. In these downhole methods and crosshole methods, they are simply digging the soils in different fields, different angles and others,
such that they have to test in a different manner. If there is any shear slides or compressive forces acting on those particular soils, what is the action on those particular methods? They have to do their investigations on those conditions also while taking these values. Simply it is called as a multi-channel analysis of surface waves. That means multi-channel, until they are not going in a single way in a different directions. They are analyzing the soil properties and giving the superior values. That means you have to design the structure by using those superior values. Next one, we are having a seismic cone penetrating test. That means seismic cone penetration test. It is a version of the downhole method where a seismic receiver is incorporated with the conventional cone penetration testing method. That means seismic cone penetration testing is the one of the method which was developed to know the data. That means soil data in the particular seismic technologies and others. That means the structure is constructing with a huge span. That means the structural importance is very high. That means the construction cost is very high. That means if the construction cost is very high, we are laying a foundation with a cheaper material. That means the total project is under danger. So that before going to construct these heavy cost projects, we need to have some sort of information about these soils, such that we need to do this kind of information. Suppose if there is any seismic zones nearer to the field, we need to have some sort of these seismic matter, such that if the vibrations are coming with some kind of 2 to 3, what we have to take, what is the preventive measures we have to take. For 4 to 5 on Richter scale, what is the preventive measures we have to take, how we have to design these beam column joints, and the foundation should be in what level we have to take. All those can be done by using these seismic cone penetration tests and their values. That means after testing these seismic cone penetration test, we have obtained some sort of values. By using those values, we have to analyze particularly on those kind of soils, what is the foundation thickness we need to maintain, at which depth of the level we have to lay our foundation, what is the minimum width and the thickness we have to maintain. Okay, what are the dampers we have to need for these kind of seismic accelerations, like that we need to analyze. Next one, we are having a pressure meter testing into the pre-bored high pressure dialtometer. That means pressure meter testing. That means if we are laying a particular these pressure holes, after the construction of the project, there may be a completely force acting on the foundation level, so that foundation have to distribute these stresses into the ground layer. Whenever there is a stress distribution to the ground layer, automatically reaction force coming from the soil to equilibrate the balance structure. That means whenever we are having a, I will wrote with some sort of information. Suppose there will be the total foundation, that means structure. From this structural point of view, we are having total weight is located on 2 points, 1 and 2, so that in the opposite direction we have some reaction forces Ra and Rb. These things we are studied in structural analysis. Those reaction forces, in which manner we are having, is there any pressure coming from those reactions to the structure. Those things we have to observe by using these pressure meter testings and others. And self boring pressure meters in few of the areas, after digging these boreholes, the water will be exerted with a huge amount of velocity and others. Why? Because of in the earth layers are very, that means the earth layers has having some amount of force exerting due to these oceanic forces and other tectonic forces they are having, so that in those likely areas the structure is in a safe condition or not. We have to take those information by using these pressure meter testings, such that In some of the areas we are having natural gas deposits and other petroleum deposits and others. That means liquid properties and gaseous properties are inserted in the earth levels due to high pressure. Those things will be measured by using these pressure meter testings and dilatometers. What is the pressure, minimum pressure exerted by the soils in the minimum layers? Okay, these are the main tests. Next one we are having is the adaptation adoption of EC7, which advocates the direct measurement of geotechnical parameters in situ testing techniques, has been a significant increase in the demand for SBP and HPD testing methods. That means SBP means soil boring tests and HPD means high pressure dialtometer tests. This is the high pressure dialtometer testing. That means HPD we are having, SBM test previously we are having. Those two things having huge amount of response for the soil parameters. That means after getting these tests on particular soils, we have to get the values as early as possible. That means we have to use these kind of testings for knowing the soil parameters and other geotechnical parameters and investigations. So all those are very much useful for knowing the soil parameters and different values for different structural purposes. Normally we are constructing a roads for transporting purpose. That means there is no additional information is not required. Why? Because the road is normal purpose. For suppose we are constructing any dam and any other reservoirs, such that we need to know the some of the basic property. That means water logging capacities and shear forces acting on the structures and others, because of the dam is a huge cost construction, such that we need to know all those parameters. For suppose we are constructing a atomic research centers on this particular area, those atomic research centers having huge amount of importance and validation in the future generation, such that we need to go for some sort of extra tests required for those atomic research centers. Likely we are having different structural importance and different structural parameters. We need to go and we need to have to investigate for structural feasibility and facilities required on those particular areas. This is the main importance of these geographical informations and other geographical parameters and ground improvement techniques. Next one is the following a major period of investment, ECG in Institutum now offers a combined magnetometer and upgraded downhole magnetometer analysis, as well as the capability of the site clearance with potential risk of unexploded ordnance. That means here we are having magnetometer. That means this magnetometer is used to locate what is the actions, north pole and south pole. Normally with the help of these magnets we have to locate where is the north pole and where is the south pole. In our surveying also we are having these magnetic compasses to locate the actions and others, such that by using these magnetometers, is there any substances below the ground level having any much of importance value. So thus these tests are used for our feasibility and capability layers, such that in some of the places we are having huge amount of these oil and natural resources. Likely in our KG basin, recently our scientists are discussed about the huge amount of natural gas and other deposits are there. Those are more costlier than the petroleum, which was now we are getting petroleum from the Arab countries and others. That is double and triple than the Arab countries having petroleum, so that they are having more importance. Likely we have to found some new things which are encrypted in our prescribed in our earth levels. In addition to our main cone penetration tests, and rigs have undergone a program detailed republishment to the ensure the provide the best possible results. That means some sort of additional tests also we have to do for better results and better experiences. These are the things involved in those. Okay, first of all we are having these 5 points, 5 to 6 points completely about the actions we have to take. What are the penetration tests, magnetometer tests, and vertical cone tests, horizontal cone tests, and other seismic information tests. All those are related to these soil parameters. And what are the different matters involved in the particular ground layers? Is there any effect on the structure? That means different structures having different structural parameters and structural importance factors. So those we have to use all of those tests for knowing the structural importance values and other things. Next one we are having these ground improvement techniques and ground modification techniques. That means basically this ground modification, that means what is the meant by modification? Modify means simply we have to change the value. Modify, that means we have to change the certain amount of value while we are designing a particular structure with a certain amount of depth, so that the depth will not bear shear forces and compressive forces acting on the structure. So that we need to modify the depth by using another value. Likely we have to use these modification techniques to improve the soil parameters and soil values for the structures having huge amount of response. That means not response means responsibility for our future generations. Four groups of ground improvement techniques are distinguished. That means distinguished means there may be a difference between these four methods. First one is a mechanical modification. By using these mechanical modifications means normally mechanical is a word related to machines which are having moving capacity on the earth level. Those things are called machines. Normally car is a mechanical equipment, bike is also a mechanical equipment, fans and other, all those are moving on the earth level by using some sort of power. Likely this mechanical modification also we are having some kind of mechanical equipments to change the properties of the soil, so up to some level only. That means not entire the soil properties, up to some level means from the ground level up to some depth we need to change the properties. Normally these mechanical densification or modification methods are used to densify the particular soil. Normally densify means to remove the voids and the water which is present in the ground level and below the ground surfaces up to some level. For those kind of properties we are using these mechanical modification techniques. Those comes under these modification techniques of ground. First one. Second one we are having is hydraulic modification. In the term itself we are having hydraulic. That means this modification is entirely related to water. That means the fluid which was present in the particular soils. So that if there is any fluid present in the particular soil, that will affect the constructional practices on those particular soils. So that we have a huge amount of obstruction while we are constructing the project. So if we are having any amount of water on those particular structures, so that we need to modify the parameters of the soil by using these hydraulic modification techniques. Different methods are involved in this hydraulic modification. In some kind of soils we are having a huge amount of salty nature. Why? Because of this backwater intrusion into the soils. They are nearer to the seaports and other normal lakes and ponds. So they are having huge amount of wastewater collected and stacked on a particular area, so that the total water can be intruded into the soil layers, so that there may be no plants growing on those particular area. Up to 1 meter or 2 meters we are having plant height. After that we are not having plant growth because of these backwater intrusions and the salt intrusion into the particular soil. Next one we are having physical and chemical modification. Physical and chemical, that means physical means structural and chemical means, that means chemical modification means we have to use some amount of admixtures and additives and resins and intrusions. All those are comes under these chemicals. By using these chemicals we need to modify the structural parameters like bonding properties, adhesion properties, collision properties. Likely we are having different kinds of soil parameters in terms of chemical nature, we need to modify those. First of all, we are having physical properties. That means physical means particle size, particle shape, particle texture, and next one we are having different sorts of physical properties we are having. All those things we need to modify using this physical modification, and chemical modification means related to these additives and admixtures and other kind of synthetics. Next, fourth one we are having is modification by intrusion and confinement. Inclusion and confinement means confinement zones we are having. Normally confinement zones means up to some level we are not having particular properties, they are simply varying to normal fields. So that we have to remove those confinements, we have to find those confinement zones in those particular fields, and we have to replace those confinement zones with another sorts of materials. All those are comes under this. Okay.